an artificial intelligence method for the analysis of marketing scientific literature by Antonio Hyder from Hackerson Founders Research and Ranjan Nag from the Stanford Distinguished Careers Institute and also R42 Institute. In our research in progress, we suggest a machine-based literature reading method specific to marketing science. And for doing this, we adopt artificial intelligence developments made in the research field of materials. In this presentation, we describe how marketing science can be extracted from documents, classified and tokenized in individual words. This could eventually be used for the automated formulation of hypotheses in marketing science. We finish by giving recommendations for next steps. The acceleration of scientific discovery is essential for human progress. However, researchers have become much better at the generation of information than at its use when tackling issues where scientific knowledge is required. Keeping up with publications is unsustainable, even within specialized fields, as over 1 million articles are published every year. The manual extraction of research information requires substantial human effort. Research overload and growth represents a bottleneck for scientific progress. It is increasingly harder to assimilate and relate research or even to figure out the role of a piece of knowledge. Also, recognizing new questions or hypotheses to be asked could become increasingly challenging. Artificial intelligence can assist in these processes. Scientific documents, natural language processing, and text mining. Scientific research documents are commonly presented in the form of scientific articles published digitally. Natural language processing, or NLP, is a subfield of linguistics and computer science which is concerned with how to program computers in order to process and analyze large amounts of natural language data. Text mining are algorithms for the extraction of information from text documents, and combined NLP and text mining can be used to retrieve scientific information. Usually, in artificial intelligence, large data sets are required for training neural networks. But instead of data sets, our key idea here is that research knowledge can be efficiently encoded as information-dense word embeddings with or even without human supervision. An embedding is a vector representation of words, that is, how words relate to each other in a given context, such as a marketing topic or the combination of concepts. Artificial intelligence in marketing science. The greatest advances of artificial intelligence machine reading have been made in hard science fields such as material science or biology. Marketing science could indeed benefit from adopting artificial intelligence for text mining, analysis, and predictive writing in marketing. The acceleration of knowledge with artificial intelligence could also open paths for transferring research to practice. Our method. So we suggest a method specific to the field of marketing science. It is based on the developments of Shitoyan 2019, Kim et al. 2017 in the fields of material scientific research. There are 3 steps here. Compile bodies of marketing research, trading the embeddings with marketing abstracts, and thirdly, repeat these 2 steps with additional topics. The first step is to compile consolidated bodies of marketing research. As a starting point, we compile, say, research and offline topics such as advertising, retail, or tourism research. This we do following the method of knowledge extraction and relationships for the handling of large bodies of scientific literature developed by Shitoyan et al. In 2019. This is conducted with the Crossref API in order to retrieve large lists of article DOIs. APIs are used by publishers such as Elsevier or Springer to download full-text articles. The knowledge can then be encoded as information-dense word embeddings, and for this we use Word2Vec, which is a machine learning algorithm. In step 2, we train the embeddings with the abstracts from each of the topics, as we mentioned, advertising, retail, or tourism. And for this, we use abstracts from 1975 to the year 2021 from more than 1,000 journals and marketing-related articles. The performance of the algorithm is believed to improve when irrelevant abstracts are removed. The remaining abstracts will then be classified as relevant or irrelevant and tokenized. And for this, we plan to use an adaptation of Chem Data Extractor by Swain and Cole, developed in 2016. This should result in a vocabulary of thousands of individual words. We will now show an example. So to train the embeddings, say we use 1 million scientific abstracts. This should result in a vocabulary of about 500,000 words. Applying the word-to-vec algorithm, target words from the field of marketing are established, which are then trained to predict context words that appear in their proximity within the literature. So the key idea here is because words with similar meanings often appear in similar contexts, the corresponding embeddings will also be similar. So on the left column, you can see how we have inserted 2 marketing words, data and tourism. These target words are represented as vectors, and these vectors are used as inputs for a neural network which is trained to predict all words mentioned within a certain contextual distance in the literature from the target word. So basically, if we input, for instance, data and tourism, the probable suggested outputs here are destination, hotel, beach, smart speaker, and space tourism. So here the researcher can figure out how he can or she can develop hypotheses to develop new work based on probable relationships. So in the third step of the method, what we do, or what we suggest we do, is to repeat the first 2 steps, integrating the offline topics we mentioned with the equivalent online topics, in this case, online advertising, online retail, and online tourism. At this point, we will stop and we will assess what happens when combining offline advertising with the corresponding online advertising, offline brick and mortar retail with online retail, and offline tourism with the equivalent online tourism. The lessons learned when dealing with the research topics may help us inform analysis made with the equivalent online topics. So the objective of this work in progress, is to define a potential method for the analysis of marketing scientific research, making use of artificial intelligence adopted from other fields, as we mentioned, mainly materials research. Usually progress happens when there is collaboration between artificial intelligence experts and domain experts such as marketing scientists. It is well known in artificial intelligence that progress is usually achieved with inevitable frustration. Therefore, focus, patience, time, and resources are required, knowing that for sure obstacles will be encountered ahead. So in our foreseeable struggle, we should not lose sight of our ultimate objectives, which include resolve research bottlenecks with artificial intelligence, aiming towards integration and interpretation of knowledge, and accelerate scientific discovery, which indeed should be measured. So as a conclusion, we expect that our method would eventually be able to analyze marketing scientific literature by using artificial intelligence and machine learning. We shall follow ongoing developments that happen in the most advanced fields such as materials. As we advance, we can also include other topics, say product distribution or education. Our next steps include developing predictive writing using bidirectional encoders, specifically BERT and ELMO. With this, automated hypothesis formulation in marketing could be possible. We are also interested in the transfer of knowledge to practice, especially to startups, many of which operate in tech, are initially small, and usually have limited resources and demand to have in time the right knowledge in order to reduce their trial and error and scale up quicker and better. Regarding our limitations, at this stage we are still unclear if this what we have presented will work well, even appreciated within social science research. Thank you.